Hi, welcome to Algebra 1 SOL Prep Week 4. This week's lesson is divided into two parts. This is the video for part 1. You received a handout that goes with this video lesson. At the top of those notes, you have information on how to solve the problems. Immediately under that, we have some examples. We're going to be starting with the examples and referring back to the notes. In this first example, they tell you that Kristen solved this equation, and they show you the steps she followed to solve it. They ask you what property justifies her first step, in other words, right here, in the solution. This information refers to properties that are at the top of your notes, such as these. Well, let's see. You're going to look at the original problem, and here's how these work. You look at the original problem and you see how it became the second line, and the property used to make it become the second line is what we write. I can see that they went from having parentheses to not having parentheses, but nothing changed on the right hand side. So what that means is that they must have eliminated these parentheses by multiplying like this. That sort of multiplication is called distributing, which is what we have here at the top of your notes. And so we're going to select option D. That is the distributive property. In this problem, they're asking us to identify the properties that justify the steps below. So we're going to be using our properties. So I'm going to drag the information that you have on your notes about properties. Particularly when we're solving equations, we're going to be dealing with properties of equalities, because we know that we do the same thing on both sides of equations when we're solving equations. So the way this works is you go to the first step that's given and you see what happened, what changed from the first step to the next one. Follow that step to the end, and where that arrow is, that's where you're going to write down what happened. Notice that on the right hand side of the equation, nothing changed. The 8 and the negative 4d are still there. The changes occurred on the right hand side of the equation, where we had parentheses and all of a sudden we don't. How do we get rid of parentheses when we're solving equations? That's right, we distribute. So this step is the distributive property. Now let's see what happened from the second step to the third one. Follow that step to the end, and that's the row where you're going to write that. In this case, I can see that the 36 is still there and the 8 is still there. But something happened with this negative 4d because it is gone. If we think about it, they must have canceled it with a plus 4d, and what they did on one side, they did on the other side, added the 4d on this side also, and these 4d plus 3d must be how they got to 7d on the second side. So they added 4d to both sides. That is the addition property of equality. Let's see what they did from the third step to the fourth step. We can see that the 7d is still there, but something happened with this 36. They must have subtracted the 36 to cancel it out, and what they did on one side, they did on the other, and 8 minus 36 is where that negative 28 must have come from. So subtracting from those sides of the equation should be the subtraction property of equality. Lastly, checking what happened from step 4 to step 5. Follow that arrow, that's where you're going to write down the answer. They divided by 7 to cancel it out, and what they did on one side, they did on the other. Negative 28 divided by 7 is the negative 4 they have there. So they must have done the division property of equality. Remember, the properties that talk about doing the same thing on both sides are the ones that end up with the of equality. For this problem, we are going to use this part of our notes that shows us how to solve an equation. Of course, if you already remember how to solve an equation, go ahead and do it the algebra way. But if you're at the test and you get nervous and you don't remember how to solve an equation, there's these steps right here that show you how to solve the equation using the calculator. You're going to get your calculator And you see how the equation is separated into two parts. There's a part that's on the left, and there is a part that's on the right of the equal sign. Remember that the equal sign separates your equation. Well, you're going to get your calculator and you're going to treat these as two separate mini equations, work each part at a time, and the solution is going to be the intersection of these two, because only where the left side and the right side are found together at the intersection is where you're going to have your solution. So let's see how we find that intersection. Remember that to enter equations, to look at their graph intersection, you go to the y equals. So whatever is there, you're going to clear it. And in the first y equals, you're going to enter the left hand side of your equation exactly the way you see it. So you enter the 3, 6, and the rest of the left-hand side of the equation. Notice that I used x instead of b. It doesn't matter which letter you use, because your calculator has the button for letters. For x, just use x. On the right-hand side, you're going to enter the other part of the equation, the 5x plus 7. You're going to look at your graph. Remember the graph button right here. And then, as a graph, keep in mind that there is a place where you can calculate the intersection. The button right next to the graph that says trace, you're going to trace and calculate that intersection. Notice how trace, oh, here it is. Please calculate that solution for me. The x value of that intersection is going to be your answer. Because calc is in the blue menu, you're going to have to press the blue button second and then press on calc, and you see the intersection right there. It's the 5th one down. You're going to select that one, the intersection. All you have to do now is just keep pressing enter. The calculator does it all automatically for you. It's going to think up its solution, and at the bottom it's going to show your solution. It's going to say x is equal to, in this case, negative 0.75. It's going to give you a value for y, but we're not interested in y. The first one, the x, is the solution we're looking for. So in this case, your solution is x is equal to negative 0.75. You write it down. If you are asked in the SOL to write that answer in fraction form, your calculator does that too. Remember, you can just exit out of there, second quit, and enter your negative 0.75, and remember the math enter function changes that into a fraction. So x would be negative 3/4. If you get a box entry where you are supposed to type in your solution, remember that to type in a fraction, you would type in the sign first, the negative, then the numerator 3, then the slash for the fraction, and then the 4. That's how you would type in your answer. The next problem can be done the same way. You can get your calculator, go to y equals, clear out what you had there before, and keep in mind that you're going to separate your equation into two chunks, the left side, the right side. Go to your calculator, type in your equation, each side on a different y equals. Look at your graph. Oops, sorry, look at your graph here. Pressing the graph button. Depending on how you're zoomed in, if you're zoomed in further, you may not see the intersection on the screen. It does not matter. You still do the same steps. You're going to calculate the intersection. So notice calculate is in blue on top of the button next to graph. So second calc, you're going to look for that intersection. 5, enter, enter, enter. So 3 enters. Look at your solution. X is equal to 1.2. X is equal to 1.2. Notice that that 1.2 is not showing here. So you're going to have to change that 1.2 into a fraction to see if it matches this 6/5. So 1.2, math, enter, enter, and that's the 6/5. So your solution is here. Let's look at another example. Again, we are going to do the same procedure. We're going to go to the y equals, clear out whatever you had there, and enter both sides of the equation. The left side as 1 in y1, and the right side in y2, just like this. Each side on its separate y equals. You're going to look at its graph, and you're going to see something interesting here. The intersection does not show. They kind of look like they're parallel, but we're not sure, so we're still going to do the second calc, find that intersection if there is one, 3 times, enter, and notice that it's going to say there's an error. So it doesn't even find an intersection. What that means is that your answer has no solution. No solution because there was no intersection. This example, we're going to work on it the same way. We are going to type the left-hand side of the equation into y1 and the right-hand side of the equation into y2. When you type these, please make absolute sure that you are typing in those negatives. It's easy to accidentally not type them in. You might not get the correct answer. So always double check when you've typed them that you've typed them exactly the same way they show. When you look at this graph, you're going to see how the first equation is going to mark, and then the second equation is going to show up in red here. This shows you that it's still working. See, it plotted exactly on top of the other one. So that means that they're touching everywhere. So when the lines are one on top of the other one, and you can make sure that they plotted one on top of the other one because the calculator doesn't show like it's processing anymore. Both lines are sitting right there, and you saw one plot right on top of the other one. That would mean all of your numbers, all of the parts of the line coincide and they all intersect. So that would be your answer there. Let's look at the next example. Here they're asking you to solve a literal equation. A literal equation is an equation that has many variables, for example, a p, an l, and a w in this case. And they're asking you to solve for only one of those variables. Solve for w. So that's the only variable that we're going to be treating as the variable of interest in this problem. What that means is you're going to treat all the other terms as if they were numbers, and this is your variable. So we're going to rewrite your equation here, and we're going to pin down the variable they're asking me to solve for. So what that means is that any terms that do not have that w on that side need to go away. So I'm going to subtract the 2l from both sides. That means that this is canceled out. Now you can't take 2 L's away from the letter P. So you're going to have to just write that what you got is P minus 2L because you cannot combine those things. And here you still have a 2W. Next, remember that you just want the W. You don't want this 2 in front of it, so you need to cancel that 2 out. How do you do that? By dividing both sides of the equation by 2. This gets canceled out, and you have W is going to be equal to P minus 2L, that entire thing on the entire side of the equation is divided by 2. This is your solution, which matches with option D. They just wrote it flipped over, but it's the same thing, so your option D is your answer. Here we need to solve another literal equation. They're asking us to solve for a letter, and the equation that they give us has a lot of letters. So it's another literal equation we're going to solve. We're going to use a different method. This method is also shown in your notes. So what they first tell you to do is that in the given equation, find the variable you're asked to solve for and rename it x. So in this equation, I'm just going to rename this my x. So it's going to be 3x minus 2k is equal to 2, and I'm looking for x. Then I'm going to pick, I already did this step, now I'm going to do this second step. Pick any value from 2 to 9 for each of the other variables. What other variables do we have here? In this case, we only have a k. So I'm going to call k is equal to 2, and I'm writing them down. Step number 3, substitute the chosen value in your equation. So we have 3x minus 2 times my 2 that I chose, the value for k is equal to 2, and then I can simplify this. 2 times 2 is a 4. Alright. Then they ask you to solve for x. So now this equation looks like the equations you're very familiar with in solving for x. So we're going to do that. We're going to add 4 to both sides. And you have 3x is equal to 6. Divide by 3. And then x is equal to 6 divided by 3, that is a 2. So what they're telling me is that if I plug in a value of k is equal to 2, I should also get an x equal to 2. So that's what we're going to check in each one of these options here for A, B, C, and D. So that's step number 4. For each answer option, also substitute the chosen value to see if you get the same value for x. So let's try option A. I chose k is 2, so I'm going to keep using that value. In this location of k, I'm going to put a 2. We use our calculator to evaluate that. So green y, enter to go to your fraction, and you're going to do 2 minus 2 and your substituted value of another 2 over 3. And it tells you that c is negative 2/3, but I was supposed to get a 2, so a is not it. Let's try again with b. Here in the k there should be a 2. So you go to your calculator. Let's type in our new equation here. 3 parenthesis 2 with another parenthesis of 2 plus 2 close parentheses. Let's see what we get. We get an 18, but we were supposed to get a 2. So that's not it. Let's try the next one. I'm going to substitute my value of k here. This should be a 2. So I go to my calculator, green y, enter for a fraction, and I type that. 2 parenthesis 2 close parenthesis minus 2, all of that over 3. Hit enter and you get 2/3. So this is not the value of 2 that I'm supposed to get. So let's check if it works for D. For option D, I'm going to substitute my chosen value for k of 2 right here where the k is, and use my calculator to evaluate. Green y, enter for my fraction. 2 parentheses 2, this time it's plus 2, all of that over 3. Hit enter, and I finally get a 2, which is what I was supposed to get when I solved my original equation. So my option is D. So this is another way of solving literal equations when you don't remember how to rewrite. Rewrite is quicker, but if you forget how to rewrite, you can always use